All right, I'm probably going to apologize here real quick. I have no idea how long this video is going to take. It's kind of a big section to get through, but I hope it makes sense to you, and let's talk about it when you get back in class. So let's get right into this, as you're going to know everything you possibly want to know about polygons here in the next couple of minutes. So first of all, if I identify a regular polygon, what that means, I'd like you to write this down, is that the sides and angles, all sides and angles are congruent to each other, okay? So if I was to go ahead and draw a regular triangle, just trying to keep it simple here, all the sides and all the angles would be congruent to each other, okay? An interior angle is an angle on the inside of a polygon, okay? So one interior angle would be any of those angles here, an interior angle. An exterior angle is an angle formed, you want to write this down, an angle formed by the extension of a side beyond the vertex of the angle, okay? An angle formed by a side that is an extension, how do I say that again? An angle formed by the extension of a side beyond the vertex of the angle. What I mean by that is this. If you have, again, I'll go back to my nice, neat triangle here. An exterior angle would be something like this right here. I'm going to extend that beyond. This one would be my interior. This would be my exterior. You guys know that already. We've talked about that. Okay. A diagonal basically is a segment that connects two vertices. Now, the key with the diagonal here, and I know you guys know this already, if I go ahead and draw a pentagon there, a diagonal cannot be drawn from this vertex to this vertex. That's just the line segment, or the outside segment. But it can be drawn to that one, it can be drawn to this one, but it cannot be drawn to that one. So just keep that in mind, how to draw a diagonal, because that's what we're going to get to down here. Now, the names of the polygons. Let's get after these. Triangle. Nobody better get that one wrong. Okay. Next one, a lot of people get this one wrong. They think square, wrong. Quadrilateral. Quadrilateral, okay? All four-sided polygons are quadrilaterals. This specific quadrilateral is a square, yes, but I want the general term, which would be quadrilateral. This one is a pentagon. This one is a hexagon. Okay. 5, 6, 7. This one is a heptagon. Stop sign for those of you that are starting to drive. Octagon. For the top of the back side. This one has 9 sides. I'm going to go non-agon, my personal favorite. And this one has 10 sides. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10 sides. So this one is a decade, a decagon. Decagon. And then this one, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we're going to skip the 11-sided polygon. This one's going to be a dodecagon. Okay, dodecagon. Okay. If there's an undetermined number of sides, n sides, I'm going to say that this is an n-gon. So what I'm trying to get at right here, when I show you an n-gon, is the fact that if I give you anything above a dodecagon, I'm going to give you like a 15-sided polygon. I'll say it's a 15-gon. Okay, so we just replace the n with the number and move on. Okay, now here's the important part. Okay, number of sides. Better not get any of these wrong. 3, 4, 5, 6, 7, 8. Okay, number of triangles. Well, how many triangles are there in a triangle? There's 1. How many triangles are there in a quadrilateral? Now, the key here to figure out number of triangles is to draw from one vertex. So I'll go from right here, and I'll draw on the number of triangles from right here. There's only one diagonal I can draw, so there are 2 triangles. The pentagon, you saw me do it up above. How many diagonals can I come from one vertex? Only 2, so there are 3 triangles there. Okay. The hexagon, I'll come from this vertex here. There's 1, 2, 3, 4. Okay, I hope you start to see a pattern there. Here we can go 1, 2, 3, 4, 5. Okay, and you can keep going on that. Now, going back to what we knew earlier this year, we have one triangle. So that is 180 degrees. Okay, here we have two triangles, 360 degrees. I thought I said three triangles? Sorry, two triangles, 360 degrees. Three triangles here would make 540 degrees. Okay, four triangles, 720 degrees. 5 triangles, I end up with 900 degrees. And then this will be 6 triangles, so we have 1080 degrees. Okay, so hopefully you're seeing that pattern that it's forming amongst all of these. So again, number of sides, 9, 10, 12, there are n sides right here. Okay, a lot of times they're going to write it with a lowercase n, so I'll do that just so you can, you might see it somewhere else like that. So number of triangles, as I went back through all the previous ones without drawing them out, do we see a connection here? There's 2 less triangles than the number of sides. So I'm going to go ahead and do this. 7, 8, and 10. And there's 2 less triangles than the number of sides. Okay. Now from here, let's see here. We were just on 1080. So this is going to be 1260. Doing that in my head there. This one's going to be 80, 1360, 1440. Okay. 10 triangles, 1800. Okay. So you may be thinking to yourself, well, what goes here? Well, it's the actual formula. Okay, and the formula is this. What I've been doing is I've been taking the number of triangles and multiplying it by 180. Number of triangles, let's just do that to make sure. 7 times 180, 1260. 8 times 180, 1440. 10 times 180, 1800. Okay, so if you take your number of triangles and multiply that by 180 degrees, you're going to end up having the sum of the interior angles of the polygon there. Okay, so I hope I wasn't too far off page there. I just realized my camera wasn't where it was supposed to be. Okay, I'll put it back up there. There you go. Now from here, this formula right here is the sum of the interior angles of a polygon. So I'm going to go ahead and do this. N minus 2 times 180 degrees. Okay. Now, what is the measure of the sum of the interior angles of a polygon with the given number of sides? So if I have 15 sides, I'm going to plug that 15 in for that n, and I'm going to multiply it by 180. So I have 15 minus 2 is 13 times 180. So 2,340 degrees, okay, in a 15-sided polygon. Okay. For the next one, how many sides does a polygon have if the sum of the interior angles are one of the following? Okay. Well, what I'm probably going to do is I'm going to set this equal to our n minus 2 times 180. Okay. Now, there's multiple ways you go ahead and solve this. I think most of you would probably distribute that 180 into the parentheses and solve it from there. I'm actually going to go ahead and divide by 180 to get rid of the 180 here. So we end up having 5,760 divided by 180, which is 32. And now I can go ahead and add 2 to both sides, and this gives me the number of sides. Okay. Number of sides there. All right, now, expounding on that a little bit, what's the measure of one interior angle of a regular polygon, okay? Now, if I was to take a 9-sided polygon, let me go back to the nonagon, okay, the nonagon. Each of these angles is the same measure, okay? Every single one of them has the same measure. So what can I do? Well, I could take the sum of the interior angles and divide it by 9, and that would give me the measure of the one angle. So if I go ahead and do that, another way of writing that out, one interior angle of a regular polygon, actually let's just do that. It was 1260 divided by 9. So if we do that, 1260 divided by 9 gives me 140 degrees. Okay, now I can guarantee this one's going to be a whole number. This one might not be. Okay, so you can round it to the nearest tenths place. That's fine with me. Okay. How many sides does a regular polygon have if one of its angles is the following? Okay. Before I go about doing that, let's go ahead and talk about the formula here. What did I do back in number 4, part B? Well, I took the sum of the interior angles. Okay, remember that formula, and divided it by the number of angles, or the number of sides, the same thing. That's all I did. So, as I look at number 5, part A, I know some of you might get kind of scared with that 17/29. Don't be, okay? I'm going to set this equal to that formula right there. So I'm going to put this over n, and then we have n minus 2 times 180, okay? Now, if I'm going to go ahead and solve for n here, the first thing I'm probably going to do is multiply this side by n to undo the division, and do the same thing with the other side. So you have 167 and 17/29 n is equal to n minus 2 times 180. Okay. Now, again, there's other ways that you go about solving this, but what I think I'm going to do is I'm going to distribute that into the parentheses. Okay. Now from there, if I want to get n by itself, I'm going to bring this 180n over to the other side. So I'm going to subtract 180n. Okay. And let's see, off the top of my head, 180, so we're going to have a negative value here. The difference here is 12 and 12/29. Okay, now, here's how you can make sure you get that right, okay? In this calculator right here, I'm going to take 167. Actually, you know what? I think I can go to math. Fraction button right here. I think I can do this right here. Okay, clear that. Let's do, watch what I do here. So I've got my fraction, got 167, 12 divided by 29. Okay, now we're going to subtract 180 from that. Okay, now I get this number right here. Really, I can leave it just like that, negative 365 over 29. Okay, that's the same thing as negative 12 and 12/29. Here's how I can tell you that. If I take negative 365 divided by 29, okay, if I take negative 12 plus 12 divided by 29, oh, hold on. Oh, here's why. Yeah, I just realized that. Negative 12 minus, because we're going greater negative here, 12 divided by 29. What just happened? Oh, I have to put in parentheses. Negative 365 divided by 29. Sorry about this. And then you have negative 12 minus 12 divided by 29. I do something wrong here? 13 12 180 minus 12. So well 180, I'll take minus 167, 13 minus 17 divided by 29. Okay. And 12 plus 12 divided by 29. Oh, I don't understand why that didn't work out before. Negative 12 minus 12 divided by 29. Okay, it was good. I don't know what I did wrong, but yeah. So this right here, these are both the same. Okay. So from here, sorry for that prolonged part right there. What I'm going to do, you can actually make this a decimal, but I'm going to divide this by this amount over here. Okay, so negative 360, watch how I do this in the calculator, divided by negative, and again, you can put this in if you want. I'm going to do the improper fraction, 365 divided by 29. Okay, and so in the end, how many sides? Did I lose something in the process there? All right, I apologize. I just realized I wrote this out incorrectly, and that's why everything was giving me this issue for the last couple of minutes here. This should have been 360, okay? So if I go ahead and take negative 360 and divide that by negative 360 over 29, that gives me 29 sides, okay? That took me a lot longer than what it should. Now, what's nice is I did the hard one for you with 17/29. You got an easier one, which is 135, okay? So see if you can figure out the number of sides with that one. As I move down here to the next part, it says identify the measurement of each interior angle within each regular polygon. Then create one exterior angle from each vertex. Okay, so if I was to do that, one interior angle here of this quadrilateral, if I go back to the front side, the quadrilateral has 360 degrees. So if I want to figure out one interior angle, I can divide that by 4 and get 90 degrees. Okay. Now, I think I want to do all of these here. Okay. So it says there should be the same number of exterior angles as interior angles or sides of the polygon. So if I look here, if I extend this beyond, extend this one beyond, extend this one beyond, and extend this one beyond, what we notice is that each of these angles is going to be 90 degrees. Okay? And so if I add up those 4 90-degree angles, all the exterior angles here add up to 360 degrees. Okay? Now this one is a 2, 4, 6 hexagon. Again, I'm going to extend them just beyond. Just like this. Okay, looks kind of like a ninja star. And so if I want to figure out one interior angle, hexagon has 720 degrees. We're going to divide that by 6. 720 divided by 6 gives me 120 degrees. So each of these angles, notice the bigger the polygon becomes as far as the number of sides, the larger the angles will have to become. So this is going to be 60 degrees here. In fact, all of them will be 60 degrees to make 180. And so we have 6 sides, each angle, or 6 angles, each angle is 60. So 60 times 6 is 360 degrees. Okay? Interesting. So if I go to the next one, what do we have here? 1, 2, 3, 4, 5, 6, 7. So it's a heptagon. That's 900 degrees divided by 7, sorry. Clear that. 900 divided by 7 is going to be, 128.57. I'll just put 128.571. Okay. Now, as I extend out the side length here, here, at each of these vertices, there should be just one exterior angle. That's kind of the key. Okay, so if I take 180 minus what was given to us there, okay, 51.43 should be our, or 51.429. Okay, that's the measure of that exterior angle. Now, if I take that amount right there, and multiply it by 7, because there were 7 sides, 360 again. So what I wanted you to see by doing that little experiment there was that the sum of the exterior angles of all of these figures will always be 360 degrees. Okay? Can you determine the measure of the one exterior angle? So if I have 3 exterior angles, remember 1 at each vertex, and I want to find one of them, I can take 360 and divide that by 3. Okay, that would be one exterior angle. For the decagon, I can take 360, remember, they all add up to 360, divide it by 10, and one exterior angle would be 36. Now you notice, 3 sides, not very many, which means the interior angle isn't very much. It's only 60 degrees. So the exterior angle is an obtuse angle. It's a big angle. If you look at this one right here, a decagon has many more sides, 10 sides. That means its interior angle is going to be bigger, 100 and, what would that be, 44 degrees, versus the exterior angle, which is now acute. Went from being obtuse to acute. Okay? So what's the formula I can use to find one exterior angle? Well, I think the easiest thing to do is to take 360 and divide it by the number of sides. Okay? So again, you can do other methods. You could take 180 minus the interior angle. Okay? But I think that's the easiest right there, 360 divided by the number of sides. Last, I'm going to let you do the rest of these on your own, but I'm going to do number 11, part A. How many sides does a regular polygon have if one exterior angle is the following? Okay, so one exterior angle is this. So what I'm going to do is I'm going to say, here's my formula. I'm going to set that equal to one exterior angle. But I'm going to put it over, well, you know what? I'm just going to leave it like this. Okay? Now, if that's the case, then to undo the division by n, I'm going to multiply this by n and multiply this by n. So that gives us 360 equals 24n. Well, how do I get n by itself? I'm going to take 360 and divide by 24. So in this case, in a 15-sided polygon, what is this? One exterior angle would be 24 degrees. Okay? All right. So just a quick hint for numbers 12, part A and part B, or 1 and 2, whatever you call them. You need to figure out the sum of the interior angles of this pentagon. Okay? And set up your equation. You need to figure out the sum of the exterior angles of this pentagon, or this pentagon. And again, you need to go ahead and set up an equation and solve for x then. Okay? So, with that being said, I know that was a long video. Okay? Part of it was my mess up there. If I would have written it down right once I made the calculations. So, apologize about that. I'd like you to go ahead and finish up the rest of the paper there. Make sure you understand those formulas. You know, just pull them out of thin air, how I got them, and make sure you're able to use those moving forward. So, have a great night, folks, and we'll talk to you later.